Okay, we're here on our final example, example number 6, where we're going to use that change of base formula. Take just a moment before we do that to kind of talk a little bit about that change of base formula again. So Saul Khan goes through and he does a good job of showing why that formula is true, showing a proof of it, but he doesn't necessarily talk conceptually too much about what it is you're accomplishing when you're doing a change of base. I will try my best, and I will probably fail spectacularly here, but try my best to talk about what you're doing. So if we have an expression like log base 4 of 16, okay, we know what that answer is. We know it's 2, right? We know that 4 raised to the second power is 16. And if we're doing a change of base, if we're trying to get from log 4 to log 2, then what we're really asking is, well, think of it in terms of the exponentials. So this one is describing this exponential, 4 raised to the second power. So if we're trying to change this into a different base, if we're trying to change it into base 2, then we're trying to change the base of the exponential description as well. So we're trying to say basically, if I don't want to write 16 as 4 raised to some power, if I want to instead write it as 2 raised to some power, what is the power that I have to raise it to, right? So that would be the solution over here, right? We know that this answer is 2, right? That the exponent we raise 4 to is 2. Now we're saying, what is the exponent that we raise 2 to? Okay, what would be the exponent there if the base was different? Okay, so that's kind of the goal with the change of base. We're trying to say, what would we have to raise a different base to get to the same answer? Okay, well, one way to try to approach that is you could say, well, what do I have to raise 2 to get to 4? Right? Because if what I'm looking for is, 4 squared, but I want to write that in terms of 2 to some power, well, then that would be like 2 squared squared, right? If I wanted the base here to be a 2, I can write this base in terms of 2 to some power. And then we just have power rules, right? We just have, when you raise an exponent to an exponent, you multiply it. So that's 2 to the fourth. Okay, so that would tell me that the answer here is 4. 2 to the fourth power is 16. So this process of kind of changing the base of the exponent is basically what's happening over here, but in reverse. Sorry, I gotta scroll through some stuff. Um, the reason why we're doing this particular division here is because what we're attempting to do is we're attempting to reverse those operations. And when we do the operations from the exponent's point of view, you've got repeated exponents, which you multiply together. So to undo this step, we're going to have to employ some division, right? So if this step right here of choosing a different base, figuring out how to write that base to get the original base we started with, if that step creates this repeated exponentialization, um, then and that causes some multiplication between exponents, then to reverse that, we're going to have to do some division, right? And that is where this division comes from. So I don't know if I can, shed more light on it than that, but just the fact that changing bases in logarithms requires a fraction. It requires some division to be employed. I can at least point out that the reason for that is because changing bases in exponents requires some multiplication to be deployed between the exponents. Okay, so hopefully that doesn't further confuse things anymore. I don't know how much it makes it make more sense, but hopefully it doesn't confuse you worse. Either way, let's move forward. So in this example, the musical cent is a unit of relative pitch. One octave consists of 1200 cents. The formula to determine the difference n in cents between two notes with a beginning frequency A and an ending frequency B is the following. N equals 1200 log base 2 of A over B. Find the frequency of pitch A if pitch B is 1661.22 and the difference between the two pitches is 1600 cents. Okay, rather wordy problem here. Okay, so we're going to take our original equation that they described. We're going to plug in the two values that they give us. So we're going to plug in 1600 over here on the left. And we are going to plug in 1661 for B. So that'll get us to this expression with two values plugged in. I don't have my pen icon. Let's just go through. At that stage, we'd be able to divide each side by 1200 so that we could just get that by itself. Okay, let's go over to where it actually shows those values plugged in. Okay, so we would plug in those two values, 1600 and 1661. We would divide by 1200 on both sides and simplify the fraction on the left. 1600 over 1200 would simplify to 4/3. And then we would have this, log base 2 of some quantity. We want to change the base into a common logarithm. So we want to get to log base 10. And just recall how we do that. We just say, okay, log base 2 of this should be equivalent to log base 10, the implicit 10 in there, of the same thing divided by log base 10 of the original base we were working with. Okay, so these would be the series of steps that you'd go through, and then you'd use a calculator to solve for A. So you'd take 4/3, multiply it by whatever the value of log 2 is. Okay, then you'd have some number over here equals log of A over 1661.22. You could use a calculator to set that up and find the answer to that value, which would in the end be 4,186 hertz. Okay, don't get too caught up on struggling through this one for too long. This is a fairly high level, difficult conceptual question to get through. That's why it's the last one. So if you made it this far and you're feeling anywhere close to confident on this lesson, then I commend you for your great intelligence and diligence. And I wish you good luck with the rest of the lessons. From here on out, the next things that we do in logarithms are going to be called natural logarithms. I talked about that a moment ago, a couple videos ago, I guess. And that is just talking about logarithms with a base of e. So kind of reversing the e to the x function to get what's called the natural logarithm. And that'll be next week. And that'll be the end of this logarithm topic. So good luck this week. Good luck next week. After that, I think things will come back to a much more conceptually straightforward series of topics that will be a little bit less twisted mentally to get through. All right. Have a wonderful day.